Well, hello, ladies and gentlemen, and whoever may stumble upon this video. I'm doing this video as a supplementary video to some of my lessons. From time to time, you'll see in your lessons that I use a graphing calculator. Now, we no longer use a graphing calculator in class because graphing calculators are old and obsolete. However, instead of reshooting the entire video, I'm just going to shoot this supplementary video on how to use Desmos, which is what we're going to use now. So, the first thing you're going to say is, what is Desmos? Well, Desmos is a graphing calculator software. If you have a handheld device, you can get it as an app. It's a free app. You can get an account that goes with it so that you can save your stuff, but it's still absolutely free. And you can use it from any web browser by just going to desmos.com. I'm just going to type Desmos into Google. Whoops, that's not Desmos, but anyway, it's the first one that comes up, even if you spell it wrong like I did. And you'll see you go into this and we're going to click on Graphing Calculator. So this is what Desmos looks like. Now, what it does is it graphs stuff for you. So we're going to start by graphing the simplest thing we can possibly graph, which is a line. I'm going to graph y equals 3x plus 4. Now, I just typed that in on my keyboard. On your handheld device or even on here, you can pull up a keyboard and get all of that information here to type in. And if you want other letters to go along with it, you can just click on the keyboard app there or back to the numbers. Okay, so this graphed the simple line y equals 3x plus 4, and you know from your work with lines that this has a slope of 3 and a y-intercept of positive 4. So we can go here and take a look. There's positive 4, and if I go up 3 and over 1, I should get to another point on the line. Every time I go up 1, 2, 3, I go over 1 and I find the line. 1, 2, 3, over 1 and find the line. So there is my line. Now, it doesn't have to be in y equals mx plus b form for Desmos to graph it. We can put it in any form we want. 3x plus 5y equals 7. And you can see we've got another line. This line, if we want the y-intercept, we can click it right here, and it tells us the y-intercept is 0, 1.4. If we want the x-intercept, we just have to go to the x-axis and find where it crosses the x-axis and click, and the x-intercept here is 3.5. Now we could do that on the red line as well, here and here. And if we want to know where these two lines cross, we can click on the intersection point and we know where those two lines cross. It's as simple as that. We don't even have to rearrange the equations to put them in. They don't even have to be in simplest form. I could put in 2x plus 5x minus 7y plus 8y equals 3. And notice it just graphs the line. It's going to simplify it and graph it all by itself. Now, if you want to get rid of an equation that you've typed in, you can click on this X here. Or if you don't want to get rid of the equation, but you want to get rid of the line on the screen, you can just click over here. Or say you want a different color. We can hold that down. Like I just clicked on it and held it down a little bit longer rather than just a single click, a click and hold, and we can change the color. We can change it to a dotted line or to that's a really dotted line. This is a dashed line and that's a dotted line. Okay, so we can do all of that on here. What else can Desmos do? Well, it can graph things other than lines. Say I want to graph a function like a parabola. Y equals 2x squared. Here's the squared down here. Minus 5x plus 6. Or let's go minus 6. That makes it a little bit more interesting because now we can see where this parabola crosses the x-axis in two spots, right there and there. And we can get the coordinates of those spots. Or where it crosses the y-axis, right there, just click. Or if we want to see where it crosses this red line, there's one intersection point, but if we take a look here, that looks like it's going to intersect again. So I can just scroll out, move it around, and click. Okay. Now I'm just using the scroll wheel on my mouse, and you can use the pinch and the zoom functions on your handheld device. If you want to zoom in, you can pinch in and out on your screen. And if you want to just pinch out in or out in one direction, you can put your fingers right on the axis. And if you pinch in and out on the axis, it'll only stretch it horizontally or vertically, depending on whether you choose the x-axis or the y-axis. So what else can I tell you about this? So I showed you how to find out where things cross. You just have to click where they cross and you're good. We can go up to the wrench, and the wrench changes things like projector mode. It'll make things bold and stick out for you. You can turn the grids on and off and the numbers on and off, or you can give something a label. Let's call this hello. Okay. Or these things, and I'm going to show these to you a little bit more in a minute, what those are all about. So I think that's basically got what we need there. Now we're just going to talk what else this thing will graph. It will graph a table of values or graph a point. I can just put any point in here. Say I want the point 1, 2. I just type in 1, 2, and I can give it a label. Let's call this point 1, 2 Charlie. So you can give it any label you want, 0.12. Okay, we're going to get rid of that. Now we're going to graph a table of values. So I have a table of values here that I'm going to graph, and we need to put that into this table here. And I'm going to show you how to put that in. We're going to put the units sold in the first column and the revenue in the second column. So I'm going to move this over here where I can see it, but you won't be able to. And we're going to type in 3,000 for units sold, 5,000, 7,000, 9,000, and 11,000. And then in our Y column, we're going to put in 16161, 24783, 34484, 34484, 38014, 38014, and 33030. Okay, so we've got all of those in, but where are they on the graph? That's part of the problem. Where are they? Now we can scroll, but we'll be scrolling for a long time because we have to go up to the 3,000s and the 16,000s. So it would be best to go here and change the scale. So my x-axis, the smallest number is 3,000 and the largest is 11,000. So I'm going to put 3,000 here at the beginning of the x and 11,000 here at the end of the x. And then I'm going to do the same thing for the y's. So if I look on here, my smallest y is 16,000 basically. So my smallest y here I'm going to put as 16,000. And my largest y is 38,000. So I'm going to put in 38,000. So you see I've got dots on the screen now, and I can scroll a little bit to make sure I see them all. Now, if I want to put a line of best fit on this information, the calculator will do it for me. So all I have to do is tell it that I want it to put it in. Now, first thing I want you to notice is that this table is table 1. We know it's table 1 because it has the little subscript 1s on the x and y. And if I add another table, so if I go here and add another table, you'll see it has subscript 2. So that's important because when I tell the calculator that I want it to put a line of best fit on, I got to tell it I want it to fit the line to the data in the first table. So here's how we do that. When I'm going to type in y equals mx plus b, and then to tell it to refer to table 1, I'm going to put a 1 here and a 1 here on my x and y. And to tell it I want it to make the calculation, I have to put a tilde instead of the equal sign. Now what a tilde is this little funny little squiggle here. On your keyboard, it's up next to the 1 key. But you see, now it puts a line on there. And it'll tell us what the slope and the y-intercept of that line is. If you take a look, it tells us the slope is about 2.3 and the y-intercept is 12,855. So it gives us the equation of the line. This here will tell us how well the line fits. The closer those numbers are to 1, the better. That's about all you need to know right now. Okay. Now, I don't happen to think that probably a line is the best thing for this. So I'm going to shut the line off because it goes up and it comes back down again. So maybe a parabola is the best thing to fit this. So here's the general form for a parabola. Instead of y equals mx plus b, it's y equals a x minus h squared plus k. And we have to do the same thing with it to tell it to refer to table 1. I got to put a 1 next to the y and a 1 next to the x, and I have to change the equal sign to that tilde. And now, that doesn't even look like a parabola, okay? But if you take a look, all of these numbers are really small. Let's see if we can get it to look like a parabola. Yep, if we zoom out, it puts a parabola on it, but it didn't really think that it was going to go up and come back down here when it used its information. Okay, so it does put a parabola on it, but it may not be what you expected it to be. Zoom back in again. I sort of thought it might go like this, but the calculator had other ideas. Okay. So that's how you get it to do lines and parabolas of best fit. You might want to write these equations down. They might be handy at a different time. Now, what I would like you to do is just play with Desmos for a bit. You can put all kinds of weird and wonderful and wacky things on Desmos. If you take a look, and I'm just going to go back to this home page, there are global math art contests for Desmos, and all of these things, you take a look at them. Some of them are amazing. Like this one here, these are all math equations, and it drew this airplane. So the people that are doing this are having a lot of fun with Desmos. Now, I don't really expect too many of you to think that that's particularly fun, but there are a few things that you can do just to get yourself customized with the calculator. First of all, know if I put in y equals mx plus b, it gives me the option of adding sliders. And if I add the sliders, that means that I can just play with the slope and I can play with the y-intercept and see what they do. It also gives me the option that I can press play and I can just watch it play with the slope itself or play with the y-intercept itself so that it's just going all over the place. Now that's not all that interesting. Okay, let's put in a more interesting equation like, well, let's put in the parabola. Y equals a bracket x minus h squared plus k. Gives us the option to add sliders. Let's see, the a makes it fatter and skinnier, flips it upside down. What's the h going to do? Whoop, moves it back and forth. How about the K? Whoop, up and down. What if we put them all going at the same time? Then we get something weird and wacky going through here. Or if you look at some of the other functions that we have on here, one of the neat ones to play with could be sine. Y equals a sine of b bracket x minus h plus k. Let's add some sliders. Let's see what happens if we get all these going at once. And it gets going around our screen just like that. Kind of weird and wacky things that's going on. So I want you to use a little bit of time right now to figure out what you're doing with Desmos, fiddle a little bit with it, maybe play with some of these things, and just get yourself familiar with all of the Desmos functions. Okay, that's it. Thanks. Bye.